First thing that we want to do here is graph this rational function x minus 4 over x plus 3 times x minus 2. And the most important thing about this graph that should jump out to you is the fact that there will be vertical asymptotes at x equals negative 3 and x equals 2. Because whenever you divide by 0 in a rational function, those are the x values that give you the vertical asymptotes. And then after that, I would find out where the zeros are, so where the x-intercepts are, and then maybe where the y-intercept is. To check the x-intercepts, you set y equal to 0. So if you set the whole fraction equal to 0, that means that the numerator is going to be 0. 0 divided by anything is 0. So if x minus 4 is 0, then x is 4. So that's where the x-intercept is. The only x-intercept. So now we got a pretty good idea about how to sketch this thing, at least what the different pieces look like, or where there will be different pieces. We don't know what they look like yet. So I'm going to make those different pieces by plotting the intercepts and the asymptotes. And then what I want to know is, where is this function positive and where is it negative? So I'm going to take those pieces of the graph that have been broken up by these asymptotes and that x-intercept and just pick a point from each piece and test it. See if the y values are positive there or negative. Because these x values, negative 3, 2, and 4, are the only places where y can switch from positive to negative or vice versa. So I'm going to pick negative 10 from the left piece, 0 from that middle piece, and then between 2 and 4 I'll pick 3, and then to the right of 4 I'll pick 10. And we could calculate the exact y values here to be a little more precise in our graph, but I don't really care about that very much right now. What I really want to know is, are the y values positive or are they negative? And the only one of these points that I'll actually try to plot accurately is the y-intercept at x equals 0. So when x is negative 10, you get a negative on top and you get 2 negatives on bottom. So 3 negatives altogether gives you a negative. When you plug in 0, you get a negative on top, and then on bottom you get positive times negative. So altogether 2 negatives gives you a positive. And you just do the same thing for x equals 3 and x equals 10. For x equals 3, you get a negative on top and 2 positives on bottom. So that whole y value is negative. And then x equals 10, everything's positive. So we at least know how this graph is behaving, where it's above the x-axis and where it's below. We also know that there will be a horizontal asymptote at y equals 0. And that's because when you multiply out the denominator here, you get an x squared plus whatever. So on top, you've just got 1 power of x. On bottom, you've got x squared. That means that bottom part is growing much faster than the top part as x gets bigger and bigger in absolute value. So far to the right or far to the left on the graph. That means as x gets really big, that whole fraction is getting really small. It's approaching 0. So on that left-hand piece, I have a really good idea of what the shape of the graph will look like because I know where the asymptotes are and I know the y values are negative. In that middle piece, I can plot the y-intercept, and I know the y values are positive, and I know there are 2 asymptotes on the left end and the right end. So it probably looks something like this parabola type of shape. And then to the right of that, the y values go from negative to the left of 4 to positive on the right side of 4. And then we still have that horizontal asymptote at y equals 0 at the x-axis. So as you go far out to the right, even though the y values are positive and they were going up, they're going to have to come back down and approach 0 again. So we've got a pretty good sketch of this graph, and I don't need it to be any more detailed than that. You can get more detailed by plugging in more points and using a calculator to plot them very precisely. You can also use calculus to analyze this curve much more deeply. It will give you more insight into what's happening. But of course, this is college algebra. This is good enough for us. So now we need to say what the domain and range are for f. And the domain is just going to be all x values except the ones that cause a problem, the ones where the function is not defined. So the only problems that are happening here are where that denominator is equal to 0. So just throw out x equals -3 and x equals 2. And then for the range, the y values, even though there's a horizontal asymptote at y equals 0, there actually is a point where y is equal to 0 on the graph. So the range is all numbers. And then third, it says to give the intervals over which f is increasing and decreasing. And it turns out that's just too hard with basic algebra that we know. So I'm not going to even attempt to answer that. We could answer it in part, but for that middle piece, for example, we don't know exactly where the minimum value is. We don't know where, it looks kind of like a parabola. We don't know where the vertex is happening exactly. And then off to the right where it has that little, where it goes up to the right of x equals 4 and then comes back down. We don't know where that maximum point is happening.